Now let's talk about inter-process communication, or what do we mean by inter-process communication. So this is a concept that we have to learn in operating system. As you all know that in modern operating system, we do not run only one process at a time. We run multiple processes at a time, or simultaneously we want to run multiple processes. Like we have the application of, let's say, the PowerPoint that I have opened. I have opened the application of Chrome. I have opened Zoom application. I have opened terminal application. I may open some other applications. So it's not like only one process is going to execute in my system. So these, what I have named right now is nothing but the application that a user is going to initiate. There are different applications which operating system is initiating, like to open this particular GUI, what is the network status about that, what are the other hardware that are there in my system, how they are attaching to each other. If I am connecting my let's say power cord, then the one application will run which will let me know that what is the status of my battery. All those things are there which are running parallelly or which are running concurrently. And I told you that what are the different scheduling algorithm that we have to use. So here we'll use either the multi-level feedback or the round robin. In that we have different categories to it, whether we have to increase the time quantum or decrease the time quantum. It depends upon your operating system, and based on that the performance will be signifies. So all those things will take place in your system, right? Now let's talk about inter-process communication. The meaning of inter-process communication is if we have two or more processes, how they are communicating with each other. So we have a process P1 and we have a process P2, and let's say these processes want to communicate with each other. So how it is possible? Okay. So what are the different ways that one process can communicate with another process? Communication means, let's say P is sending some data and P1 is sending some data and P2 is receiving that data, or P2 is sending some data, P1 is receiving some data. Or let's talk about some shared memory where P1 is doing some updation in the shared memory, and P2 is also sharing some sharing the same memory and updating something, or it is taking the updated thing. It is also possible, right? So if let's say P1 is updating something and P2 is taking the updated data, that is also possible. That is also a type of communication that two processes will do. So all those things we are going to learn in this particular topic, which is called inter-process communication, where two or more processes can communicate with each other. So the inter-process communication is the way in which processes communicate with each other. We know that the different processes are running in the system and they need to communicate with each other. Process executing concurrently in the operating system may be either independent or cooperative. So any process running into the system is of two categories. Okay, one category is called cooperative, and another category is called independent. So what do you mean by cooperative process and what do you mean by independent process? Let's see that. So the independent process, they cannot affect or to be affected by other process executing in the system. So when one process is running, one application or one process is running and another process is running, so these two processes is not going to affect each other. Means the output that one process is producing will not going to affect the input of another system. So if this is not the case, then we can say that these two processes are independent to each other. They are not dependent to each other. Getting it? So we may have different processes that are running into the system which are independent to each other. But there are many processes which are running in the system which are dependent to each other. If you'll see in this particular application, I have opened an application which is called uh, Microsoft PowerPoint, right? And I'm using it in front of you. And also I am using a touchpad where I'm writing something, right? So the application that is used in this particular touchpad is cooperating with the PowerPoint right now. So these two processes are cooperating with each other. Means these two processes are cooperative processes which are cooperating with each other. Now, what do you mean by cooperative process? They can affect or be affected by other processes executing in the system. So if one process is affected or affecting, or another process is affected by other process, that particular process or those category of the process are called cooperative process. So the cooperative process, generally what they do is they share the common thing. What are the thing that they can share? Maybe they can share some sort of variable. Maybe they can share some sort of memory. Maybe they can share some sort of code, or maybe they can share some sort of hardwares. Like maybe they are sharing the CPU, maybe they are sharing the printer, maybe two or more processes are sharing the scanner. So all those things may be shared between two processes. So if processes are sharing something, those processes are called cooperative process. If they are not sharing anything, those are called independent process. If they are sharing, definitely one process may affect another process. If they are not sharing anything, definitely those processes are not going to affect each other. Those are called independent process. Any process that share the data with other process is called cooperative process. So I think you understood the difference between the cooperative process and independent process. And you understood the meaning of inter-process communication. So the inter-process communication is required in some sort of cooperative process. So if we have some sort of cooperative process, let's say P is one process, Q is one process, and both the process are cooperative process, means both the process are having some shared resources available, and they are sharing the resources with each other. Definitely they comes into the and that they need to do some sort of communication. If they do not communicate with each other, it is very difficult to share the resources with each other. Okay, that is not at all possible. If they are not cooperating, how they can share the resource? Let's say you are sharing the hostel room. Okay, let's say there are two students who are sharing the hostel room, right? And you know that there is only one door available, right? So one door is there in which is used for going in and coming out, right? So that particular door has as a lock, right? So lock has the key, right? And let's say one person is going out and lock the door. Is a good idea? Or if both are outside and one person want to go into that particular room, so it needs the key. So one key that will be shared between these two person is actually shared between these two person, right? So that key will be shared between these two, and with the help of the key they can share the room. they can share the room. So both the person need to cooperate with each other. If one person has a class, let's say at 2 o'clock, another person want to do lunch at 2 o'clock, both can do that, right? If one person want to go to room, they can do that. So all those things can be done with some sort of cooperation, some sort of communication. So if two processes are sharing the resources, those are called cooperative process. And to work normally with the cooperative process, these two processes should communicate with each other. That is the mandatory thing. So let's talk about what will happen when two process will become the cooperative process. So there are several reasons for providing an environment that allow processes to be cooperative. Why we are doing such complex thing? If we are making our operating system which will produce independent processes, it will be very easy to manage by the operating system, right? Because they doesn't have the common resources and they don't have to cooperate with each other. But why it is required to make cooperative process? So to make cooperative process, these are the thing which is possible. The first thing that is possible with the cooperative process and which are not at all possible with the independent process is information sharing. So information sharing, what we required if we want to do information sharing, information sharing is not at all possible with the independent process. Information sharing is only possible with the help of cooperative processes. So cooperative processes can share the information. How they can share the information, that we'll see later on. So there are two techniques. Either they will share the memory with each other, or they can share some sort of variable, or they can share some sort of, so sharing is one thing that they can do with all the thing. And second is the message passing. So message passing is another technique in which the use of message passing can be done with two or more processor without sharing the resources. That is also possible. In these two mean, information can be shared between two, or information can be communicated between two processes. Second is communication speed up. We can speed up the whole communication process. In that way, we can speed up the whole processing capacity of the system. So how it is possible, how we can do is speed up. If we have, let's say, one process, that one process would be divided into number of small processes, P dash, P double dash, P triple dash, P 4 dash, in that way. So we can make, or we can divide one process into number of processes, and these number of processes we can run simultaneously into our multi or hyper threading system. And if we are doing it, we can speed up the execution speed, right? And how it is possible? It is possible to make these processes, these cooperative processes possible. Next is the modularity. One process will be divided into different modules, or one sort of code will be divided into different module, and these different module can be cooperative modules, and then they can communicate, they can execute into the system. As well as it will make convenient to the user to use the operating system if we are making a cooperative system. So let's say if we are having, we have open different applications, and these application, if you want that two application will talk to each other like this. This is one application which is used to write into the screen of the PowerPoint, right? So that convenient will be provided through the cooperative processes. So these are different reasons why we need cooperative processes. Let's say if we need the cooperative processes, then how this will be become in a reality. So it will become in a reality, or this inter-process communication is possible with different techniques. These two techniques are called shared memory technique and message passing technique. So the cooperative processes require an inter-process communication mechanism that will allow them to exchange data and information. So inter-process communication mechanism will allow the cooperative processes to exchange the information with each other. And to actually exchange the information with each other, we have the technique. That technique is called, with the help of shared memory concept, we can actually do the communication or message. With the help of message passing technique, we can actually do the communication between two cooperative processes. So let's talk about shared memory first. So shared memory is a region of memory that is shared by cooperating processes is established. So one shared memory is shared by cooperative processes, and it will establish in that way they can establish the communication between two processes. Process can then exchange information by reading and writing data into the shared memory. So as I told you, we have a shared memory. Some process is writing something into the shared memory, and some process is reading from that particular shared memory. So the concept of the shared memory will be very much useful for inter-process communication. Okay. Next is your message passing. So what is message passing? In the message passing, communication takes place by means of message exchange between cooperative process. Now these two processes can exchange the messages with each other, and that is only possible with some sort of communication passage. So you might have heard about the concept of socket programming, right? Or client server communication. So message passing is possible to the cooperative process of two different systems. So we have two different systems available, and these two systems are connected with some sort of networking technology. And there is one process, there is another process, and then with the help of this networking communication technology, these two can communicate with each other. That is possible in message passing. Okay, where two cooperative process, maybe they are not in the same system, or maybe they are in the same system but they are not sharing the resources. So both are possible. Maybe they are not belonging to the same system, or maybe they are belonging to the same system. So maybe P and Q, though both are belonging to the same system, or maybe P and Q are not belonging to the same system, but they can communicate with each other without sharing the common memory. Without sharing the common memory, they can communicate with each other. That concept is called message passing. Let's see this particular model in detail and try to understand what is this. So the first model is called shared memory model, and the second model is called message passing model. So let's talk about this. In a shared memory model, here we have a process A and we have a process B, and both are sharing one memory resource that is there, in which process A is writing something and process B is reading something from the same shared memory space. Here what is necessary? It is necessary that the shared memory should be in the address space of process A, and it is also necessary that this shared memory region should also be in the address space of process B. But actually what will happen is operating system try to give the separate address space or non-overlapping address space to the processes. But the shared memory concept in which these two processes will be agreeing into some sort of agreement, and they will tell, they both, process A and process B, will tell the request to the operating system that they want some overlapping address space, and these overlapping address space is nothing but the shared memory which they are sharing with each other. So that particular concept is called shared memory concept, in which one process is writing something. So here process A is writing and process B is reading. So that is a concept of shared memory. Now let's just talk about message passing. Now what will happen into the message passing? The address space of A and the address space of B are not overlapped, right? They are excluding to each other. Now what will happen in this? If A has a message, that message will be sent to the kernel, and from the kernel, B will read the message. So here it will send the message and it will receive the message. So sender will send the message to the kernel itself, and from the kernel, process B is going to take that particular message. Now that is very much understood through two systems. Let's say we have two systems available which has some IP address. Let's say the IP address of one system is, let's say, 172.16.22.3, and we have another system which has the IP address, let's say 172.16.22.4, and these two systems want to communicate with each other. So how they can do with the help of message passing concept? They will use some sort of port. So let's say if we have the concept of client server, so we have a client and we have a server, and what client will do is client will do some sort of request to the server. So generally we use we use the message passing through the help of some sort of port number. So we know what do you mean by port number, right? So port number is for a specific process. So let's say, or a specific task. So in the operating system, we have 1024 specific tasks which are specific to the operating system. And more than that, so we have around 6,000 ports which are available, 6,000, more than 6,000 which are available, and available ports are there. So for C, what is the communication message port with that? So it has its IP address, and then it will use the port number which are more than that. So let's say we have a port number which has been used by this client. And what do we mean by server port number in which they want to communicate? So they have the IP address as well as they have the port ID. Let's say here we have the port ID because it is going to serve something. So let's say the port ID is 80 for that. 80 is the port ID for HTTP. HTTP. So with the, if anybody want to avail the HTTP request, the port number 80 is open to the server, and it will get the request from the client related to the HTTP, and it will communicate through that particular port. So you can see that C is going to communicate with the server with this particular port and the IP, and server is going to communicate with the client with this particular IP and the port. So in that way, both will create the socket that is called socket. So both will communicate the socket. Socket is nothing but the end point by which two process can communicate with each other if they are separated with the and they are connected with the network connection. So in that way they can communicate. So we know that different ports, like for the telnet we have port number 23. For FTP, file transfer protocol, we have port number 21. For HTTP, port number 80. In that way, we have some reserve port, which is up to 1024 reserve port, which are for the operating system. And more than that, we can use it for actually the inter-process communication. That concept is called message passing. So here also, if we have two processes and these two processes are available into the same system, so they can communicate with the kernel, and kernel will communicate with these two processes. So here, which are common? Common is the kernel, by which process A and process B is executing. And the same thing we can make it with the help of this particular model, which is a socket programming, some sort of socket programming we can do, by which these two process. So this is one process and this particular is another process. So these two processes can communicate with each other. So we know the concept of inter-process communication, and we know that how it is possible and what are the ways by which it is possible. So to see that particular concept of inter-process communication, we'll see one example where we'll see a producer and the consumer. Producer is producing something and consumer is consuming something. Okay, so let's see, we have an example here. This is a producer program, where producer program is always because it is going to the while loop, it is always going to produce something. So what it is doing is, so we have a producer, we have a consumer. In between producer and consumer, we have some sort of buffer. Buffer is some sort of shared memory. So you see, we have a buffer, and this buffer is going to be used between two process. One process is a producer, another process is a consumer. Producer is producing, and what it is doing this is the infinite loop, you can say, while counter equal to buffer size. So here counter is one variable. So let's assume that the counter is equal to 5. So if counter is 5 and the buffer size, we have allocated some buffer size, so that shared memory has some size. So the counter is equal to the buffer size, then we are going to the infinite loop. It means that my buffer is full, right? So let's say the counter is how many time I have written something and how many time I am consuming something. That is a technique here we have used. Let's say the buffer size is 1, 2, 3, 4, 5, 6. The buffer size is 6. And counter I have initiated with 0. Let's say I have initiated the counter as 0. Whenever I write something into the buffer, and I'll increase this particular buffer size, I'll increase the counter value also. So I know the buffer size is 6. So this is my buffer size which is given. So let's say the buffer size is 6. So how many time I can write something on that particular buffer? So obviously 6 time I can write it. How I can count it? I can count it with the help of the counter. I can count all those things with the help of the counter, right? So one time I have written, I have increased the value. Another time if I'll write, I increase the value. So right now, if I have written one time, so let's say the counter value is 1. Now I am writing again, so the counter value will become 2. Now I'm writing again, the counter value will become 3. In that way, it will go on. So if I'm keep on writing, definitely my counter value will increase. And when my counter value is equal to the buffer size, I'll go to the infinite loop. So you can see here, this is my infinite loop that will be taking into the account, and all the time it will search for this particular condition. If this condition is true, it will go on going to the loop and it will not going to write anything. Let's go and try to understand the concept of producer. So what producer is doing, that producer is also running that particular code infinite time. Here what it will say is, while counter is equal to 0, then it will be go into the infinite loop. This particular has to write here, right? So I'll remove it. So now you can see that whenever the counter value is 0, it means that there is no code. Counter value is 0 means there is nothing into the buffer. If there is nothing into the buffer, the consumer will go into the infinite loop. If there is something into the buffer, what it will do is it will go to the location of the buffer. It will find it out what it is there. It will consume it, and then it will increase the buffer size. It will keep on consuming, and it will decreasing the counter value. So let's say right now it has 1, 2, and 3. Some places are empty right now of the buffer. So what consumer will do is is going to consume 1, consume 2, and consume 3. And then when it doesn't have anything, so it will go to the infinite loop. Maybe meanwhile producer has been wake up and producer is producing again. So right now what is the status? The status that buffer is empty right now. So again producer will produce some values here. So let's say it is producing some value. Again what will happen is, because producer has produced some value, so what is the status of the buffer right now? So the status of the buffer is this. So again consumer will see and it will find it out that the counter is not at all 0. It is 3 right now. You made it 0, but producer has made it 3 again, because it has put it 3 values here. So counter value will increase. So consumer will consume the values. So maybe they are doing simultaneously, maybe they are doing one by one. So I don't know in which way they are cooperating, but they should cooperate with each other. If they will not cooperate with each other, that particular problem is called race condition. Okay, if they will not cooperate with each other, definitely there will be the problem. That problem is called race condition, that we'll see later on. Let's talk about the buffer that we'll use. So we have two type of buffer that we'll use. Either I'll use the unbounded buffer or I'll use the bounded buffer. Bounded buffer means I should have some limitation into the buffer, and here we doesn't have any limitation into the buffer. So what will happen when we doesn't have any limitation into the buffer? Places no practical limit into the size of the buffer, the consumer may have to wait for the new item, but the producer can always produce new item. So you can see that if the buffer size is endless, so producer keep on producing the value. Producer keep on producing the value. It doesn't have to stop. But if there is nothing into the buffer, then consumer has to wait. Even though the size of the buffer is more or the infinite, but there is nothing. If there is nothing into the buffer, consumer has to wait, but producer is never going to wait. Now let's go to the bounded buffer like this that we have seen. So what will happen in the bounded buffer? If we have the bounded buffer, then producer will always have to see that whether the buffer is full or not with this particular condition. And if the buffer is full, producer has to wait. It means it will go to the loop. It will not do anything. And at the same time, if consumer is there and it will find out that there is nothing into the buffer, then consumer also has to be wait. So you see here in this particular concept, consumer and producer both has to wait, but the waiting condition is different for the consumer and the producer. Consumer has to wait if the buffer is empty, and producer has to wait if buffer is full. But in this case, consumer is waiting only for the new item if buffer is empty, but producer never has to wait. Producer is keep on producing the the values, or keep on producing the values in or items into the and putting into the buffer. So which type of buffer that we are taking? We may take this one or we may take this one, right? So in both the thing we can take, but the thing is that if we are taking these type of unbounded, so what will happen in the unbounded is our objective is not going to fulfill. Producer keep on working, keep on working, keep on working, and consumer doesn't get the chance at all. That is also possible. But here, because producer will produce some value, for some time it is not going to work because it is full. Then consumer will come and consumer will consume thing, and again the consumer will is not going to work because it is empty. So in that particular model, both consumer and producer and consumer can actually get the CPU and can work cooperative, or cooperative working is possible in the bounded buffer. But in the unbounded buffer, cooperating or the cooperative process is there, but it is very difficult to make restrictions. So this is about shared memory concept. And in this, we'll see what are the issues in this particular shared memory concept. What is the issue in the producer consumer problem that we'll see. And we'll see that if we want to make our system which will adopt the concept of cooperative processes, and so how it will adapt. So it will adapt. So the inter-process communication of cooperative process is possible through process synchronization. Both the processes, one processes may consume, one processes may produce, but both the processes should be synchronized in one way or another. So that if, let's say if two people are talking to each other, if one people will talk, then other people has to listen. If another people is talking, then this people has to listen. So between them, there should be some sort of synchronization. In the same way, processes also, if they want to communicate with each other, they should have some sort of synchronization. So that if one is sending, other has to receive, or if one is producing, another has to consume. So that concept we'll see into the next class. The concept is process synchronization.